Right, so we started off with descriptive chemistry, and we're currently looking at the hydrogen element. And like we said, we looked at the occurrence of hydrogen yesterday, and we're going to be moving on further. Okay. Now let's go to page 65. The hydrogen consists of one proton and one electron. Right, on that paragraph. Everyone with me? Right. Most of the chemistry of hydrogen can be explained in terms of the tendency to acquire electronic configuration of a noble gas, helium. Right? This is it can do by gaining an additional electron to give a hydride ion, right? By sharing the electron and accepting a part of the share of electron from another atom, as in hydrogen molecule H-H, right? Showing a bond between two hydrogen. And by accepting a lone pair of electrons, which it does as a proton when it combines, for example, water and ammonia to give a hydronium ion, right? Which is a positive ion, which is H3, 0 plus, and ammonium, which is NH4 plus. Right, these three distinct types of behavior are discussed later in this module. Hydrogen can readily be obtained by the action of certain metals on water. Please highlight this. Hydrogen can readily be obtained. We're on the second last paragraph on the page. Sama? Okay. Right? Hydrogen can be readily obtained by the action of certain metals on water. Nitric acid and concentrated sulfuric acid must be avoided, right? Since hydrogen appears as water in these instances, and oxides of nitrogen and sulfur dioxide are evolved respectively. Right? Okay. Right, it is also formed when water is electrolyzed in the presence of small amounts of acids, alkalis, and salt. Steam is passed over heated carbon, and when the ionic hydride, example calcium 2 plus and H minus 2 is hydrolyzed. Right? So now we turn over, we're going to be looking at action of water on metals. Right? Today's date is the 6th of July 2023. Looking at the action of H2O on metals. Right, so remember we got this 2 hydrogen, right, plus 2 electrons will give us H2. And this here, is it balanced? Is this balanced?
Yes.
Yes. It is. And remember, yeah, so it is balanced. So this is how basically we wanted to obtain H2 here. So we wanted to, how we get H2 is by using this half reaction. This is found in our half reaction table, right, in the periodic table. Half reaction table. Behind, you know the other table I gave you? Yeah. It'll be given in the exams. This will be given in the exams, right? Right, so now we obtain H2. But remember what our action is for water on metals. So let's go on. Then we've got Metals, so this essential is a process of the hydronium ions are reduced. Since other cations besides the hydrogen ion are hydrated in water, and equations showing hydration look rather cumbersome. The simple cations will usually be written as follows, right? Metals with a high negative electron potentials, right, in group 1 and 2 react with cold water. So we're looking at this now, right? In here we've got 2Na plus 2H2O, right? Which will give us 2Na plus OH minus plus H2. And so this here, you can see all of this here is producing our it's producing our form of hydrogen, right? And let's look at another metal. Magnesium plus H2O will give us Mg2 plus O2 minus plus H2. So this is what we want. Then next we'll be looking at action of So next we're looking at action on dilute acids, right? On metals. Let's look at the explanation. Everyone done with this? So we can just pay attention to the book. Okay, so busy. Magnesium. It is showing, so remember what we say? Action of water on metals produces our diatomic hydrogen here. Right? And this is how we're getting hydrogen. We're looking at how we can get H2 being produced. Right? It happens as a byproduct when you have water acting on metals. Okay?
So even like with rust and stuff, it's basically that's what happens.
No, rust is a different equation. Rust is an oxidizing.
It's oxidizing.
Yeah.
So wouldn't you? It won't evolve.
And then so rust is
iron oxide.
Yeah,
So
iron oxide. So but iron oxide being produced from the action of what you call we have air and so we got air in water. So we got salt water. So we got NaCl and O2 and something else, and we got H2O, and then it gives off Fe2. Yeah.
So it doesn't evolve hydrogen that reaction.
No, not really.
Not really, yeah?
No, not really. Yeah. So this here is just but in terms of what's being given off and what we want is our H2. Yeah.
Okay.
So the next one we'll be looking at is the action of dilute acids on metals, right? This again is a reduction ions, hydrogen ions, right? All metals higher than hydrogen in the electrode potential series react to dilute hydrochloric and sulfuric acids to give hydrogen, right? The more negative the electrode potential of the metal, the more vigorous the reaction. And this highlight the bulb there. It says lead does not show much evidence of reaction with dilute hydrochloric or sulfuric acids, since an insoluble layer of salt prevents the appreciable action. So hydrogen is normally prepared in the lab, right? So how is hydrogen normally prepared in the lab? By reacting zinc with dilute hydrochloric acid, right? By reacting zinc with dilute hydrochloric acid, and then it gives us the 1 volume cone of hydrochloric acid to 1 volume of water. So the ratio is 1:1, right? The gas, however, is frequently contaminated by hydrogen sulfide and arsine from traces of zinc sulfide and arsenic, right, in the zinc. Right? So in terms of the reaction there, you got zinc plus 2H plus, which will result in zinc 2 plus, right, plus H2. Right? So I want you to take down that first reaction there. Then we got this reaction, right? This reaction here will become second nature, right? The 2H plus 2 electron will give you 2H. And then obviously 2H is H2.
It's near the Hoff reaction. That's all. The reaction you're showing us there, the zinc and the thing, and the hydrogen. That's only the Hoff reaction.
Yeah, this is just half reaction.
Yeah, so the hydrochloric acid, you're not showing the.
No.
Okay.
So because we're only looking at it in terms of producing this
Specifically.
on a metal, yeah.
Okay. You don't put the impurities into
Oh,
it.
you're
Yeah.
not showing.
No, it's not showing the
with
full
the
reaction.
acid.
Although it's the description is
It's
giving
not-
everything, but it's just showing us like what we need to know from the reaction, right?
Okay.
Like in the exams, what they'll do is they'll mention the action on a dilute acid, and they want you to draw these two equations. So that's why I said there's a lot of theory here. You need to remember all these equations for each one of this here. But as we go through the past year papers, you'll become familiar with the type of questions, and then quickly you can do it. It'll be easy for you. But the key thing is to like get to the past year papers and let's practice those past year papers. Sometimes you might not know the background, but you know the question. You'll know the question.